Hello students, now let us see the activity 2.4 students and try to understand what is meaning of this. They are saying place a few piece of granulated zinc metal in test tube. Okay student, take a test tube like this student, and that is you are put the granulated zinc metal Zn. Add 2 ml of sodium hydroxide. Okay, so that is in this one 2 ml what we have to add, that is sodium hydroxide student solution, and warm the content of the test tube. So what is at the end what we have to do, that is we have to heat it out student. Okay, so if you are heating this, so see, repeat the rest of the steps as activity 2.3. Record your observation. Okay, this many things. So what you are putting is student zinc Zn plus NaOH. Okay, so it will give, that is Na2 ZnO2, like that it will give the compound. Okay, so let us read out the answer student for this one. So the activity 2.4 asks us to treat zinc granulated base like sodium hydroxide. Observation: bubbles come out from the zinc granules which burns with the flame. Explanation: just like the metal react with the acid, metal also react with the bases and produce the hydrogen gas. Here zinc react with the sodium hydroxide and form the oxide of zinc with the evolution of hydrogen. The reaction is vigorous, so we use dilute bases to moderate the reaction. So here they have given a student zinc is reacting with NaOH, it is giving, that is sodium zincate. Na2ZnO2 is known as a student, that is what, sodium zincate, Zincate, sodium zincate, and that is hydrogen gas. This is the what student? This is the hydrogen gas, right student? Now let us move the another activities, that is activity 2.5 student. What they are saying, take a 2 test tube, label them as A and B. Take about 0.5 gram of sodium carbonate Na2CO3 in the test tube A, and about 0.5 gram of the sodium hydrogen carbonate NaSCO3 in test tube B. Okay, so 2 test tube they are saying student. In the one test tube, that is Na2CO3, and in another test tube they are saying, that is you take, that is NaHCO3, NaHCO3 sodium bicarbonate. After that they are saying add 2 ml of dilute HCl in both the test tube. So that is we have to add, that is HCl 2 ml, and here is also we are adding, that is HCl, that is 2 ml. Okay, now let us see the next one. What do you observe? Okay, pass the gas produced in each case through the lime water calcium hydroxide solution as shown in the figure and record your observation. Okay, so what observation? Activity 2.5 asks to react with metal carbonate and metal hydrogen carbonate with acid and see if any gas evolve. Check also the gas give precipitate with quicklime or not. So see student, carbonate and hydrogen carbonate of metal contains carbonate group CO3 in it. The metal form its salt with acid and produce carbon dioxide gas and water. So Na2CO3 and 2HCl is there, it will give NaCl H2O and CO2. NaCO3 react with HCl, it will give NaCl H2O and CO2. Carbon dioxide react with lime water. Lime turn lime lime, that is calcium hydroxide, and form the calcium carbonate. Calcium carbonate is also insoluble in water. Its power form makes water milky. Activity 1.4 like, that is calcium hydroxide, it is reacting with CO2, it is giving calcium carbonate, that is milky color. So here, that is diagram is also shown. Sodium carbonate is there. Okay, you are adding this one dilute hydrochloric acid, so carbon dioxide gas is formed. That gas is being passed with the passing with the calcium hydroxide. So it is, that is it is turning the milky color student. So that you have to keep in mind, that is how it is turning the milky color, because of formation of CaCO3. Next, what is interference conclusion? This experiment shows that all the metal carbonate and metal hydrogen carbonate react with acid and form the carbon dioxide. Now let us move out the experiment number 2.6 students. What experiment is saying? Take about 2 ml of dilute NaOH solution in test tube and add 2 drops of the phenolphthalein solution. What is the color of the solution? Add dilute HCl solution to the above solution drop by drop. Is there any color change for the reaction mixture? Why did the color of the phenolphthalein change after the addition of an acid? Now add a few drops of NaOH to the above mixture. Does the pink color of phenolphthalein reappear? Why do you think this has happened? Okay. So student, they are saying that is 2 ml we have to take, that is NaOH. Okay, and then we are adding, what is student, that is we are adding, that is phenolphthalein, that is LEIN. Okay, phenolphthalein. What is the color you phenolphthalein? What is the color change they are asking? That is they are asking the color. Okay, so it will change to the blue color, student, blue color. Okay, but we have to see. Add dilute HCl to the above solution. Okay, drop by drop. So we have to add, that is HCl also to the. Why did the color of the phenolphthalein change after the addition of the acid? So what will happening is, student, here it will be the neutralization reaction. Okay, this will be the acid base neutralization reaction. Okay, does the pink color of phenolphthalein reappear, or this is the pink color? I think pink color. And why do you think this has happened? Okay, let us see. This activity asks us to add few drops of phenolphthalein in dilute sodium hydroxide and see what happens when add to dilute acid. A time comes after adding the acid that pink solution phenolphthalein disappear. Now again, if we start adding sodium hydroxide, it becomes pink. Okay. Now phenolphthalein is a colorless reagent. It turns the solution into pink at basic. So it is used in a acid base titration to see the end point. Like here, adding acid neutralizes the base present in the test tube. Now, as the end point of the reaction, the addition of the extra drop of acid makes the solution acidic. As a result, the pink color disappears. Okay. Situation reverts when we add a base to this acidic solution. As a result, the solution gets own previous pink color. Inference: a change in color of pH indicator can indicate the completion of a reaction. Now, next activity, student, activity 2.7. What they are saying: take a small amount of copper oxide in a beaker and add dilute hydrochloric acid. Slowly while stirring, note the color of the solution. What has happened to the copper oxide? So let us read out activity 2.7. Ask us to add dilute hydrochloric acid to copper oxide and check the solution of the color. The color of the solution turn green. Why it is turning green, student? Copper oxide is black. It reacts with the hydrochloric acid to form copper chloride, and copper chloride is brown, but it absorbs water and turns the solution into green color, like that. Okay. Application: copper is the ornamental metal. Many small idols of the gods are made of the copper. This turn into black and green by reacting with the atmospheric air. People use the acidic nature of the lime to wash this color. Thank you so much for watching, friend. Other activity we will make for the another video. Thank you so much for watching till that.